This presentation has the discussions about the computer system and introductions to operating system. The contents are overview of OS, what operating system do, computer system organizations, computer system architecture. The objective is describes the general organizations of a computer systems and the role of interrupts. Describes the components in a modern multiprocessor computer system. Overview of OS. So the set of programs is a software. Two types of software: system software used to run a system or machines, application software used to perform user needs and applications. Operating systems is a system software used to run the system based on user commands. So what does the term operating system mean? An operating system is fill in the blanks. That's about the car, airplane, printer, washing machine, toaster, compiler, etc. What is an operating system? A program that acts as an intermediary between a user of a computer and the computer hardware. Operating system goals are executes user programs and makes solving user problems easier. Then make the computer systems convenient to use. Then use the computer hardware in an efficient manner. The computer system structure is the computer systems can be divided into four components: hardware, operating system, application programs, users. In the hardware, it provides the basic computing resources, the CPU, memory, I/O devices. The operating systems controls and coordinates use of hardware among various applications and users. The applications programs, it defines the way in which the system softwares are used to solve the computing problem of the users. The users are people's machines and other computers. Abstract view of components of a computer. The user performs their applications using the operating systems with computer hardware. What operating system do? It depends on the point of view. Users want convenience, ease of use, and good performance. Don't care about the resource utilizations. But the short computers such as mainframe or mini computer must keep all users happy. Operating systems is a resource allocator and control program making efficient use of hardware and managing executions of user programs. Users of dedicated systems such as workstations have dedicated resource but frequently use shared resource from the server. Defining operating systems. The term OS covers many roles because of migrated designs and use of OSs. Then presence in toasters through ships, spacecraft, games, machines, TVs, and industrial control system. Born when use computers for military became more general purpose and needed resource management and program control. So the operating systems definitions, no universally accepted definitions. The one program running at all time on the computers is a kernel part of the operating system. Everything else is easier. A system program and the application program. Today's OS is for a general purpose and mobile computing also include middleware. Overview of computer system structure. The computer system organization, where the computer system operations, that is one or more CPUs, device controllers connected through the common bus, providing access to shared memory. The concurrent executions of CPUs and the device competing for memory cycles. So where the CPU is a processor to execute the user's needs, then stored into the memory. The computer system operations. Here, I/O devices and the CPU can execute concurrently. Each device controller is in charge of a particular device type. Each device controller has a local buffer. Each device controller type has an operating system's device try to manage it. Then the CPU moves data from to main memory or from local buffers. So IO is from the device to local buffer of controller. Device controller informs the CPU that it has finished its operations by causing an interrupt. So common functions of interrupts are: interrupt transfers controls to the interrupt service routine generally through the interrupt vector, which contains the address of all the service routines. Interrupt architectures must have the address of the interrupt instructions. A trap or execution is a software generated interrupt caused either by an error or a user request. An operating system is the interrupt driven interrupt timelines. So it manages the process between the CPU and the IO request. The interrupt handling process or the operating system preserve the state of the CPU by storing the registers and program counters, determines which type of interrupt has occurred and separate the segment of code, determine what actions would be taken for each type of interrupt. Then the interrupt IO cycles. So here the CPU perform the overall processing. The IO controller it take which kind of informations to be taken and which time that is to be passed. So everything that can be handled through the input and output devices. Then the IO structure is two methods for handling the IO. After IO starts, control returns to the user program only upon IO completions. Then after IO starts, control returns to the user program without waiting for the IO completions. So here, after the IO start, the control returns to the user program only upon the IO completions and wait the instructions ideal the CPU until the next interrupt, and also wait the loop, and at most one IO request is outstanding at a time, no simulations IO processing. In the second case, it's does not wait. So for that, it make a system call the request to the OS to allow the users to wait for the IO completions, and the device status table is to maintain the entry of the IO devices. And the computer system architecture. Here, the most systems use a single general purpose processor. The most systems have a special purpose processors as well as the multi-purpose systems that growing in use and very important. So also known as parallel systems, tightly coupled systems. So the advantages are increased throughput, economy of the scale, increased readability. So it has the two types of the multiprocessing: asymmetric multiprocessing, symmetric multiprocessing. Okay, thank you.